Hi guys, it's Drew again from the Radio Geeks, playing you another video showing you how to configure the Jonathan Naylor software packages he has available. This time we're looking at DstarRepeater. As you can see, I'm using the Raspberry Pi with the Raspbian operating system. This is the image of Brian, GW6WTK. It's a very good image. It's probably one of the easiest ways to get your Pi up and running. So we're going to our terminal manager, and when that opens we will type in there sudo DstarRepeater Config, and that's all one word, DstarRepeater Config, and thereafter we'll put a ampersand. Now if you're not aware, if you put an ampersand after your program, it actually freezes the command window. So it gives you the ability to run other things in the command window. Simple. So as you can see, if I run the program up, there's the dstar config program. But if I come back onto it allows me the option, I can do similar, I can type different commands, etc, etc. So if I wanted to bring other programs up using the command window, or if I wanted to change various things using the command window, it frees it up. If you didn't put that ampersand, as soon as you closed the program would lock. So if you closed the command window, you would end up closing the dstar config program. If you wouldn't be able to use the command window for any other actions until you actually closed our DstarRepeater software, config software. The system is exactly the same as our IRC-DDB configuration, series of tabs running across the top of the program window, and we'll click on each one in turn and configure or tell you what the meanings are as we go. So the Callsign window, we put the call sign of our repeater, the call sign of our hotspot. If we're not running a repeater or hotspot, if you have a personal node, then your own personal call sign can go in there. We have the modules. This particular instance of the program will run 5 different modules, so you can have 5 separate instances of this program running, each designated with a separate module talking back to one instance of IRC-DDB. So as long as your hardware can handle the load, you could have up to 5 different RF applications running under the different module numbers. I'm going to stick with B, which is our 70 SEMS module. It's really a gentleman's agreement that the A module is 23 SEMS, B module is 70 SEMS, C 2 meter, D is 6 meter, and E is 10 meter. Now that's how it's universally agreed. You don't necessarily have to follow that, but it'll make it a lot easier for people to realize if you have a B module, they're going out on 70 SEMS. If you have a C module, they're going out on 2 meters. Our gateway. Well, this is the gateway call sign of our IRC-DDB program. It usually follows suit that it would be the same as our call sign within the configuration here. You can run separate calls, but if you're doing that, if your system needs you to do that, then you're probably a little beyond this simple configuration video. You would to contact the IRC-DDB group to allow your system to work over multiple call signs. But generally, the gateway call sign follows the module call sign, and of course we have the G designator there, which we can't change because it's a gateway. Our node is a drop-down box for configuration as a duplex. So if we have a repeater whereby the transmitter would be keyed on receiving a valid DStar signal, So you're transmitting, so the box is actually transmitting and receiving at the same time, i.e. a repeater. That's our duplex operation. Simplex, that's listening while you're transmitting, and of course transmitting while you're listening, so that's simple simplex. The gateway mode, again, is a little bit beyond this this simple config, but essentially if you run the program in gateway mode, if you had a repeater on a hilltop location but you didn't have any internet access, then if you ran this program in gateway mode, it would transmit and receive from and to the repeater. So essentially the repeater would see it as a standard user, but of course you're transmitting and receiving using the repeater's call signs. It's a very good way of getting a signal up to the repeater, getting a network signal up to the repeater if you haven't got any internet on site. And as is usually the case, if you have a fantastic RF site, they're usually quite difficult to get any infrastructure to it. The next selection, TX only, well, I think that's self-evident. If you're running over multiple locations, so for example you could configure so you have a remote transmit site or you have a remote receive site, and that would pass the data over the internet to your hilltop repeater. So you could have a fill-in receiver perhaps, or a fill-in transmitter, as well as the transmitter and the receiver at the repeater site. So now we have our TX and RX selection. That's usually used with the split repeater software that's Jonathan's released. So again, if you're setting that up, that's a little bit beyond this simple config tutorial. Okay, the ACK selector is another drop-down box. The ACK, or acknowledgement, is essentially on receipt of our signal, the system would send us back an acknowledgement to say that we hit the box. So if we didn't want that, we could switch it off. We have the option of sending back in the acknowledgement our bit error report, so it can tell us what how it received our signal, or we can use it as a status report, which is forwarded from IRC-DDB. So if we were connected to a reflector, or if we were not linked, the text acknowledgement would give us that status information. The restrict box, a simple on or off selection. Now the restrict box would be useful if you were running a personal node. If you had a DVAP or a something similar where only yourself using it on a personal thing, this would tie it to the call sign in our selection box here. So if we had our personal call sign in there and we had our restriction on, only the call sign listed here would be able to access and use this module. So it's a way of preventing third-party traffic being sent over a personal node, should you not have a notice of variation on your license for a hotspot or a repeater. Repeat one validation, again a simple on or off command. Essentially what we're saying to it is, if the repeat one is exactly the same as our call sign with the module, pass the traffic if it's switched on. If it's switched off, it will pass any traffic regardless of our call sign setup. DTMF blanking, again an on or off selection. This would pass or block the DTMF tones. So if you were connected, if we had our personal node or if we had our hotspot connected to a repeater, if someone on that repeater keyed up and used DTMF tones with the blanking on, you wouldn't hear those tones. With the blanking on, you would hear those tones. Now we'll click upon our network tabs, and if you've watched our IRC DDB gateway config, you'll probably recognize this because it's almost identical to the setup on that program. Our gateway address, that's the address, the IP address of our IRC DDB machine. So because in this instance IRC DDB and the DstarRepeater are running on the same hardware, we're using the 127.0.0.1 IP. If we had a separate machine running our instance of IRC DDB gateway, then that's where we'd enter the IP address of that particular machine. And we have the same setup here with the gateway port. Again, that would be the input port of IRC DDB, the port that it's listening for the data that the DstarRepeater is sending it. Our local address, that's the IP address of the machine that's running the DstarRepeater program. Again, in this situation, both IRC DDB gateway and DstarRepeater are working on the same hardware, so we're using the 127.0.0.1. If you had your DstarRepeater running on a separate machine to IRC DDB gateway, then the IP address of that hardware running the DstarRepeater software would be entered into this box, and our local port is the port number that our DstarRepeater machine is listening for the data back from IRC DDB gateway. These four boxes cause people the most amount of anxiety when setting up these two programs to work together. So just to recap, gateway address, that's the IP address of the IRC DDB gateway machine, and the gateway port is the port of the machine of the IRC DDB where it's listening for data from DstarRepeater. Our local address, that's the IP address of the PC running DstarRepeater, and our local port is the port that DstarRepeater listens on in order to get its information from IRC DDB. These two ports are usually configured as default, and if you leave them alone, you shouldn't go wrong unless you're running multiple systems, multiple connections. So probably best to leave them in their default state and just concentrate on our gateway addresses and our local addresses, and leave the port numbers as are. So there we go, that's those four boxes. Now we'll move on to our timers tab. Looking at the timer tab configuration, we have only two things to adjust here. First of all is our timeout timer. Well, again, quite obvious, this is how long the transmitter will transmit your over. Most of the original ICOM DSTAR boxes were configured for a 3-minute timeout. On all the systems I've configured, I like to chat a little bit longer than that. I'm a bit of a rag chewer, so I've set that slightly higher at just over 4 minutes. But if you happen to be configuring this system to work alongside a hotspot or a personal node or something similar, and you're going to spend quite a lot of time attached to the local repeater, which happens to be ICOM hardware, then it's probably advisable that you set that for around about 3 minutes. Also our ACK timer, well, you don't usually need to adjust that. Depending on what hardware you're running, sometimes you would need to adjust the ACK time, but 9 times out of 10, if you leave it at the default setting of 500 milliseconds, you shouldn't have any issues. Our announcement tab. Our announcements are switched by enable disable, so a simple selection there. If we enable it, we have a slider here which adjusts the timescale where the announcement is selected. So we can, in this instance, its default setting is 8, so we could set this so that the announcement would be transmitted every 8 minutes. Now, the sort of announcements that people are transmitting are dates of club activities, sort of general information that they want transmitted out. You have the ability to remotely record our announcements should you wish to change it on the fly. So you would configure a new repeat 1 setting, a new repeat 2 setting, and with those settings set the same in our radio, when we transmit you would be recording a new announcement. So that would take over from the original announcement. It would overwrite whatever announcement you had there originally, and of course you can delete the announcements as well remotely over RF using a delete repeat 1 and a delete repeat 2 call sign. Again, these would have to be set in your radio, and a quick key up using the repeat 1 and repeat 2 that you've selected for delete would delete the announcement, and then you would have no announcement to delete. So hopefully I've explained that. So if you want to record a new announcement, you have a separate repeat 1 and repeat 2 for recording a new announcement. If you wish to delete the announcement you recorded earlier or you have set on your machine, you would use the repeat 1 and repeat 2 that you've selected and configured to delete the announcements. And again, towards the top here, the slider simply suggests the increments that the announcement is transmitted, so every 30 minutes. Moving on to our beacon tab. Again, the same setup. We have a slider which gives us the increments in time of how often we transmit our beacon. You have your message which is transmitted with the beacon in our slow data text, and we have the ability to also send that message that we configure there as spoken word. So I've enabled that as it's a personal hotspot. I've left the duration to every 30 minutes. I've also enabled it to transmit the word personal DVAP in spoken word as well as our text transmission, and the drop box below gives us the ability to set our language. Although I'm based UK, I do actually prefer the US announcements. So there's our configuration of the beacon tab, our transmit of our beacon, the text message we want to send with our beacon, whether we want the beacon text to be spoken as a voice transmission as well as the text transmission, and what language we would like that voice announcement to be in. Our modem tab. This is probably going to take the longest amount of time in order to to go through the various configurations, because as you can see, our drop down menu configures for all the different types of modems that are available for DStar. So we have a DVAP, we have a GMSK board, we have the 3 different types of DV repeater cards, and we have our sound card configuration, our PC sound card configuration. As said, I'm running with a DVAP because it's a personal node, so I will select DVAP. Hitting the configure button gives the configuration settings specifically for the DVAP. Now these would differ for the different types of hardware you're using, as selected up here by this drop down box. So the DVAP settings are the USB port it's connected to, whether you're running it on as a 2-meter DVAP or a 77s DVAP, your transmission frequency, your power output level, your squelch threshold. That's the configuration for the DVAP. But as said, that would differ. For example, if I were to use the GMSK board and I hit the configuration for that, the only configuration in there is of course the hex address for our GMSK board. Again, if I would change that to a DV1 card from the German group, again you can see that changes the configuration screen once again. So in this instance we have the USB port that the device is connected to, whether our start delay is enabled or not enabled, whether the TX inversions and RX inversion settings are enabled on or off, which one of the 2 pins we're using on the device to get our DStar signal, whether we're using the A FSK pin or our B AFSK pin, and of course our transmit TX level and our transmit delay setting. Now these are all specific to the DV repeater 1 card, so as I say, you would need to first of all select the device you're using. Then once selected, the configuration would change depending on the hardware you're using. First of all, select the device you're using. Then once selected, the configuration would change depending on the hardware you're using. As I'm using the Raspberry Pi, as you can see on the sound card settings, we're using the Ulsa mixer. There is no microphone port on the Raspberry Pi. It cannot accept a sound card input, so therefore that is blank. Now if you were running with one of the USB fobs, then obviously you could set that as your line input. The Pi does have a audio output, so that's automatically been detected for us. And again we have our RX and TX signal inversion, our RX modulation level, our TX modulation level, and our TX delay. So again, each one of these settings would differ depending on what hardware you're using. The Control 1 tab, this is a handy little tab if you have a remote location. Should you have to control the DStar repeater from afar, we can configure a repeat 1 and repeat 2 command. So in my instance we'll use let me as repeat 1. I'll use in this example control as our repeat 2. So setting repeat 1 to let me and repeat 2 to control, I now have the ability to shut down, i.e. pause the the software, the DstarRepeater software. So if I had to temporarily perhaps take our repeater off air, I could send the command in the UR field of down and transmitting with the repeat 1 of let me and the repeat 2 call sign of control in my radio. That would now put the DstarRepeater software in a suspended state. I could bring it back up again by sending the UR field up as configured in my radio, and that would put the device back into action and continue under normal service. We also have the ability to call the 5 inputs of the development board, which Jonathan recommended with his original setup within the repeater softwares. So the development board has 5 digital IOs, so you can set them all as inputs, and then giving a UR perhaps of stat1 with the let me control repeat 1 and repeat 2 settings would give you a text transmission with the data on the stat1 status 1 pin of the development board. Again, stat2 for example would give us a text transmission of the data on the input 2, and vice versa for input 3, input 4 and input 5. And we also have 4 digital outputs on the board, which again we could call with a UR of out1, out2, out3 and out4, etc. by setting our UR field to out1, transmitting again using the let me control repeat 1, repeat 2 call signs in your radio would give you the status of the output pins of the development board. This is very handy if you happen to have your repeater on a remote site and you would want to gain access to those datas on the various pins. The Control 2 setup tab, we can use a UR field, but this time using the repeat 1 and the repeat 2 call signs of the DSTAR module. So your personal hotspot call sign or your repeater call sign, but this time we use the UR fields shutdown or reboot, and then in this box here we actually configure the command that we want to send the operating system. So I can remotely shut down my Raspberry Pi by using the shutdown command in the UR field, or I can remotely reboot my Raspberry Pi using reboot in our the UR field. So we've got 4 different boxes there that we can configure, and of course you're not limited to just rebooting or shutting down the operating system. You could also manually start or stop a program that you have on your PC. So if you had to control something at the repeater site, for example, as long as you have the hardware connected, some remote USB relays, something of that, etc., as long as you can call them using a DOS command, or in the case of Linux, a command line, you could make good use of those at your remote site. Our final tab on our DstarRepeater is our controller. This is usually used along with the sound card configuration in our modem. There's our sound card configuration. The controller tab would allow us to set a COM port, a serial USB, or a Arduino, the Veteran board, or the our basic USB to serial type device, and we can use that set device to key our radio whilst our COM port is transmitting. It allows us to key the PTT for the Dstar transmissions. As you see, there's a fair selection here that you can call depending on what hardware you have connected to the device. You also have the ability to use the GPIO pins of the Raspberry Pi as well for PTT keying should you wish. The other thing we could do with this particular configuration window, if we're not using our sound card and we don't need PTT command, we could use any of these pins to drive a relay to switch an external cooling fan. So every time our transmitter starts to transmit, through use of a keying relay, we can turn that fan on and off, which would be quite handy to keep our transmitter cool should we need it. So we'd need to use some form of keying circuit and use a relay to switch the fan on and off. So I wouldn't advise anyone to connect a fan directly to a GPIO pin or connect a fan directly to our serial pin. Also on this tab we have 3 different configure states of our serial port. So essentially what they do is they use different pins of the GPIO or different pins of our serial port in order to use as the keying pin. So you have the ability to use either the RTS pin or the DTR pin, and we also have a time delay which we can set. So if we used it with our external fan, for example, we could say don't actually close the circuit until 60 seconds after the transmitter has stopped keying. So we could have our fan run on for an additional 60 seconds. Or if for any reason you have any sort of delay on your PTT within your radio, then you could also extend the PTT keying time using this slider here. But generally, for the configuration within our modem tab, the first block of devices have the built-in keying abilities. It would only probably be used for our sound card selection or for use with an external fan. So that's the configuration of the DstarRepeater software. In order to save our configuration, we would need to click on the file command. We then use save, and it gives us a little GUI warning to say that the configuration we just saved will not be instigated until we restart our Dstar software. As you can see, I'm not actually running the Dstar software at the moment, so as soon as I start it in a moment, the new configuration will be put in place. To close the configuration GUI, we click the exit command, and there we have it. That's the configuration of the Jonathan Naylor G4KLX DstarRepeater software. Okay, so I hope you found something of interest within these couple of tutorials we've done in configuring the software. Maybe next time we'll bring you a configuration video of some of Jonathan's earlier softwares. So for example, if you're using his GMSK repeater or DVAP node, maybe even his dummy repeater software. So keep an eye out for the next installment from the radio gigs. 7.3.